Electrochemical principles of metallurgy. See, we have seen the thermodynamic principle in which we mainly decide that whether the reaction will be feasible or not on the basis of the delta G values. But yes, how we make it feasible is by increasing the temperature. Now, in case of electrochemical principle, what we emphasis on is that we know there are metal ions, we can say there are situations in which what we find metals are present in the form of their ions or oxidized state in the solutions or in the aqueous state. Now, they are to be taken out from those aqueous or from the solution state. So, when they are present in this oxidized state, they are to be reduced to their metallic form. Now, for this reduction, we need to give them what? The electrons. Now, this reduction basically can be done with the help of what? Electrical energy also. And the relationship which plays an important role in this is that the delta G naught is equal to minus NF E naught cell or E naught reaction. Now, here we will take the standard reduction potential. We have done this relationship in electrochemistry chapter. We know N is the number of electrons exchanged or electron accepted, F is the Faraday's constant 96500 coulombs, and E naught is the standard reduction potential. Now, if suppose the reduction of a metal ion to metal is having a large negative E naught reduction value, we can easily imagine we cannot reduce it simply by using any other reducing agent. So, this usual reduction processes are used whenever the metals are having a low E naught reduction values. Whenever these are high, definitely what we have to do is we have to use electrical energy as a source, and that's why those processes becomes what we call them electrolysis. But yes, the metals which are having higher reduction potentials can easily be reduced by more reactive metals. Like we can take the example of, suppose we have a copper ions. Yes, we can use any of the metal which are lying above copper ions in the electrochemical series, since copper is already having a positive E naught reduction value of 0.34 volt. Yes, we can use any one of these. Like if we are using iron solid, we must know the copper is reduced and Fe gets oxidized to ferrous ions. So it's a very normal electrochemical process in which what we have done is, since the reduction of this was very much feasible, it was actually done with the help of ferrous iron, which gets oxidized to ferrous. Or what we can do is, if we are having suppose any other metal which is present in its ionic form and its reduction is actually having what? E naught negative. So remember, if E naught is negative, this negative will become delta G positive, and once the delta G is positive, that means that reaction is not feasible. We can make it feasible what? By clubbing it, by coupling it with another reduction process or another oxidation process in which E naught reduction is negative. So what happens is, when the total overall E naught reduction, what becomes is, when the E naught values of both these added, it becomes positive, so that the overall delta G becomes negative. So that's the basic principle behind the electrochemical principles of metallurgy, and it is used in number of different examples. Like let us take the example of aluminium. What we can do in this case is, like we know in case of aluminium, what we find is that we have already got pure alumina. We have got pure alumina from the Bayes process, but now we have to what? Reduce it. Now, aluminium is very reactive metal. Its E naught reduction is very much negative. We cannot use any other to reduce it as such, because the other substance which is formed should not be fusible with the metal. So we are left with no other option to use what the process called electrolysis. In order to make this process, this reduction of aluminium from Al3 plus to aluminium by the use of external source of energy in the form of electrical energy, and the process is called electrometallurgy. Now, in this what we use is we do the electrolysis of this. Now, when the electrolysis of alumina is done, it is done by adding taking it in the fused state. Now, in the fused state, it is mixed with NaAl, Na3Al, F6, which is called cryolite, or we can take small amount of calcium fluoride in this also. Now, the main purpose of adding cryolite and the calcium fluoride is that they reduces the melting point of this alumina. They increases the conductivity, and that is why the process becomes more feasible. Now, what is done is, we can easily understand this. When this is taken in the fused form, Al2O3, we take cathode and anode, and they are connected through the electrical source. Now, what happens is, we know Al2O3 will break down into Al3 plus and O2 minus. We know what will happen at cathode. The aluminium will go there, will accept electrons, and will get reduced to aluminium. Now, therefore, a cathode is taken as of steel. Now, anode, at anode, what happens is, oxide gets oxidized to like this one, O2 plus what we can do is 4 electrons, but actually what happens is, anode is always taken of graphite. So, this oxygen form combines with the carbon of the graphite to form CO2. So, it is the CO2 which is obtained at the anode, and it's not basically the oxygen which is obtained, and this is how the electrolysis of aluminium oxide is done, which is called Hall's Heroult process. Hall's and Heroult process, this is one is called. We can use also this technique for the reduction of copper. Specifically, what we can do is low grade copper ores. Whenever we have a low grade copper ores, where we find that the percentage of copper is not much, we can reduce it with the help of using hydrometallurgy. Like, we can use the reducing agents like hydrogen, which very easily reduces this into copper, and itself gets oxidized. If it is present in the form of copper oxide, like this one, we can write, if it is CuO and H2O, you need to understand what happens is water is formed. Or we can use scrap iron for this purpose. The iron being more reactive in this reduces copper to copper, and it itself gets oxidized to ferrous. So, the same basic principles are used of the electrochemistry to reduce lesser reactive metals like this by more reactive metals with more negative E0 reduction values by electrolysis.